There's some more word problems dealing with exponential functions. Um, we did the compound interest, where A is the final amount, P is the initial deposit per loan, rate is your interest rate is a decimal, N is the number of times you compound in a year, and T is the number of years. So you just have to think of a year when you divide it up. I mean, quarterly, there's 4 quarters in a year, semi-annually is 2, compounded monthly is 12. You could say that, you could say weekly, that'd be 52. You could say daily, that'd be 365. So you just have to think of a year. Okay, so if $1,200 is invested, so this is your principal at a rate of 2%, which you have to divide by 100. This is R. Compounded quarterly is 4. That is N. How much will you have in 3 years? That is T. So we are given everything we need to fill out the formula. So A will equal $1,200. Parentheses 1 plus the rate, which is 0.02, which you divide it by 100, over the number of compounds, which is 4, and that's raised to the number of compounds times the time, which is 3. And so basically, if you think about this, PEMDAS says you need to do what's in the parentheses first. Then you will need to raise the exponent next, and then you will need to multiply it by the 1,200 as last. So this is first, this is second, this is third. So you have to think about that when you're doing it. So you can say, okay, parentheses 1 plus, and I'm going to break the fraction of 0.02. Hold on, clear this. I'm doing something wrong here. 1, well, hold on, clear. Let's do 0.02 divided by 4. Let's just do that. Okay, and then we will add that to 1. So we'll say plus 1. So now that's what we call our growth factor. So 1.005 is our growth factor. Okay, and this time we're going to raise it to the 12th power. So we are going to raise it to 4 times 3, which is 12. And then once we get that, we will multiply that times our principal, which was $1,200 times 1,200. And you hit enter. Oops, do that. You hit enter, and you get 1274.01. So round to nearest penny. So it is 1274.01. Money. Pause it if you need to. Okay, now we could type the whole thing in. Also, we could say 1,200 parentheses 1 plus, and then bring out the fraction. Put 0.02 and then divide it by 4. Close it and raise it to the 12th power. You can see we get the same answer. So one way if you don't have a graphing calculator, and the other way if you do, you can just type it all. Okay, next problem I'm going to, so pause if you need to. Okay, so 15,000 invested at a rate of 4.8% interest compounded monthly. How much you have in 2 years? Okay, so pause it, give it a shot, and then come back and see the worked out solution. Okay, we're back. We invested 15,000. We divide our rate by 100. Compounded monthly is 12. That's N. How much will you have? So that's A is the question mark in 2 years, and 2 is T. So we are going to say 15,000. On this side, A over here, parentheses 1 plus 0.048 over 12 times, raised to 12 times 2. So again, you can just, once you write it down, 15,000, parentheses 1 plus bring it fraction, 0.048 over 12, close it, raise it. 12 times 2 is 24. Your answer, round to the nearest penny, you'll have $16,508.22. Pause it if you need to. Okay, so compounded continuously, it has to say those two words in the problem. If it says those two words in the problem, then you do A equals P. E is the base number on your calculator, so you just locate it. E, if you hit the second button and then the button that says LN, that will bring up E, make it to the first power, and that tells you how much the value of E is. Okay, it's an irrational number that never terminates and never repeats, so 2.718 is a good rounding. So that's what we call a natural base. Okay, so E is the natural base. And this happens whenever something grows continuously in life, like anything in nature. Okay, so that's where we use the number E for. Okay, so it says populations of bacteria, radioactive decay. It's used for continuous growth or decay. So now our rate and our time are our exponents, so they will get multiplied in the exponent region. So we need to know less for this. So basically, Malcolm deposits $2,400, so $2,400 is his principal. It's going to be compounded continuously, so E is the next part, and your rate has to be divided by 100, so it's going to be 0.0196, and you will multiply that times the time, and you will just plug it all in and get your answer. So 2,400, and then second LN brings up E, and then parentheses 0.0196, close of parentheses 4, close it, enter, and we get 2595.73. That's about it. Not a whole lot of problems that you will have to do on that, but whenever you see compounded continuously, just remember the formula is PERT. Okay, pause if you need to. I'm going back a screen or 2 screens. So if it says compounded in it and it gives you a number, you will use this formula up here. So if they say like compounded monthly, daily, weekly, whatever, use that formula. But if they say compounded continuously, then that is the formula that you use. Pretty cut and dried. Okay, so I gotta pause for a second. I'll be right back. Okay, so now in this problem, they give us a formula. They just say $24,000 car is expected to depreciate at a rate of 8% per year. The situation can be modeled by Y equals 24,000 times 0.092. See, it's less than $1, so that's decay. Raised to the T. How many years is the car first worth less than $15,000? So this is just a mere investigation. So basically, you are putting the value in your calculator of the formula, and you're applying the base, and you're going to raise it to a value until, and then you can hit second enter and recall your, until you get what the desired result is. You keep it second enter and just build back over and over, right? They gave you the formula so you can use it. So it seems to be, how many years is a car first worth less than 15,000? It seems to be at year 6. Year 6, solidify. Okay, the next problem here. Let's work this one 2 different ways, and we'll make this the only future example of this. The rest we will save for homework problems. So Sarah Wong invests $41.29 in a retirement account with a fixed annual interest rate of 4% compounded 4 times a year. What will the account balance be after 14 years? So let's do it compounded 4 times. And let's just change it for a part B. For part B, same info, except compound continuously. So we're going to change that stipulation in A. So we'll say this is part A, and we'll say that that's part B. So part A, the formula would say, well, we don't know A, but we know the initial investment, and we know that the rate is going to be divided by the number of compounds, and we know the number of compounds is going to get multiplied by the time. Okay, well, and in part B, we would say, well, it said compounding continuously, so we know the formula is more simple, so we just use the rate, or the initial amount, I'm sorry, for the principal, 129, and we use the base E for compounding continuously, and then we're going to say that the interest rate was 0.04, and then the time was 14. So let's see what the difference is in these two. And I won't beat you to death on the notes about this. So I'm going to say 41.29 parentheses 1 plus the fraction 0.04 over 4, close it, and it'll raise it 4 times 14, I think it's 56, and hit enter. So we can say, okay, that way was 72, oh wait, 0.45. And similarly, we say 41 to 9, and we bring up our natural base, and we raise it to 0.04 times 14. And we get 72, 28.53. So this this grows quicker. And it's better investment. Never stops growing, grows continuously. Whereas this one only grew 4 times a year. So it's what, 20 bucks. 20 bucks is 20 bucks. Okay, pause it. And I'm going to the next screen. So this is a basic table trying to show you what yearly growth rate means and what monthly growth rate means. So I'm going to do some work below on the first one. It says A T is equal to 500 times 1.9 T, and they, or raised to the T, I'm sorry. Drag this all down. Do that. So that's basically, so the initial amount is going to be the 500. Now, the yearly growth rate, we need to do a little bit here. We need to think about R is the rate of growth. So this is 1 plus R. Let me say 1 plus R equals 1.9. Therefore, R, or my growth rate, is going to be 0.9. Because that's how we get that calculation. That's how we get, and we call this in here we call this in here the growth factor. That's the growth factor. The whole thing together, growth factor is the 1 plus the R. But the growth rate is just the R part. Now, how do we get the monthly growth rate? Well, monthly growth rate's a little tricky. Okay, with monthly growth rate, what we have to do is we have to sort of take our growth factor, which in this case was 1.9. And we say, well, what would that be if we had it into 12 equal increments? Well, the thing about growth, it's repeatedly multiplied, so it's exponential. So monthly growth rate, you have to say that's raised to the 1/12, okay? Now, to find out the growth rate, you have to take out the principal once you've done that. Okay, so keep that in mind. So now to do this, I would say, okay, I'm going to take my growth factor of 1.9 and I would raise it to 1 / 12, and then I would subtract. Okay, and that gives me a value of 0.0549. So that's equal to 0.0549. I could say 5.49%. Okay, and hopefully that would make sense. Okay, so that's how you find your monthly growth rate. Now, in the next one, I'll do it in a different color. It appears that our principal or our initial amount is 1.7, so that's where we began. And this is seriously growing. In here is a 5, right? So remember that part comes from 1 plus R. So here it has to be 4. Now, if you think about it, this makes 90%. This makes 400%. That's really growing, right? Cooking with Crisco. Now, to figure out what my monthly growth rate is, I have to take the entire parentheses and raise it to the 1/12. And then I have to subtract out the principal. So I can say that is 5 raised to 1 divided by 1/12, and then I need to subtract the 2. Okay, so 0.1435. So I'll say that's equal to 0.1435. Now we could say that's also 14.4%, something like that, you know. We could say that. Okay, now you try the third one. You get the third one shot. Pause your screen, you get the third one shot. Go over it. Okay, so remember we're focusing on the couple parts here, the initial amount, and this problem is a -4, right? Now, when we talk about the growth rate, remember this whole thing is 1 plus R. So that means our growth rate here would have to be 2.2 or 220%. So we're really growing on some of these problems. I wish my bank account would like this. So now when we do the monthly rate, we're going to take what's in the parentheses, which was 3.2, raise it to the 1/12, and then we're going to subtract the original amount that was invested. So now that's going to be parentheses 3.2 close it raised to the 1 divided by 12. So we'll break it into 12 repeated factors, basically. And then we are subtracting 1, which was the original amount invested. And so that gives you 0.1017. So that's 0.1017, which you could also say it's 10.2%. Or 10.17%, how people say. So pause if you need to. I'm going to the next screen. Okay, so now we're looking at exponential decay. So this is when your base is between 0 and 1. Okay, so your principal amount is what's in front of the parentheses, so there's going to be 21,000. But this time, as you go along, it's going to get smaller. Now, underneath here is 1 minus R. So this is what we call our decay factor. Now, they use different words here, so make sure you understand the right word. So to figure out the rate, we got to do 1 minus 0.72. Okay, so 1 minus R equals 0.72. So if I say 1 minus R equals 0.72, then R is equal to 1 minus 0.72, which R would then be equal to 0.28, and that would be my yearly decay rate. Now, to do monthly decay rate, I would still take what was in the parentheses originally. I would take my decay factor, 0.72, and I would raise it to the 1/12. But this time, I would put the 1 in front. So since it's the decay rate, 1 minus that, because it's getting smaller. If you subtracted 1 from it, you'd get a negative value. So you got to reverse the subtraction. So basically now we will say 1 minus, and then 0.72, and then we would raise that to the 1/512. And we get 0.027%. So that's, no, that's just 0.027. So 0.027 means it will be like 2.7% as your monthly decay rate. So I got to pause. So, okay, so let's try the next one, and then you do the last two. So we have 20 is our initial amount. We're going to say 1 minus R is equal to 0.85. So 1 minus 0.85 is equal to R. So then R is equal to 0.15. So we'll say this is 0.15. So that would also be 15%. This could have been 28%. Okay, so just keep that in mind. Now here we're going to say 1 minus what was in the parentheses, which was 0.85. And you raise that to the 1/12, and that's for the monthly rate. So you put that in your calculator, and you get 1 minus, and parentheses 0.85, close it, raised to the 1/12, and you get 0.013. Or 1.3%. Okay, so you pause it, you try the last two, see how you do. Okay, we're back. This is 5. This should be 0.3 or 30%. This should be 1 minus 0.7 raised to the 1/12. That gives me 0.029 or 2.9% monthly decay rate. Last one, my initial was -2. So that would have been 58% for a decay rate. And I would say 1 minus 0.42 raised to 1/12. And we get 0.069. Or 6.9%. Okay, pause if you need to. I'll go to the next one. Okay, using the given model, what is the value of the house in 2 years? Okay, I say that's the model as the value of the house after 2 years. I'm sorry. What is the yearly rate of growth or appreciation? So again, 1.2 equals 1 plus R. So 1.2 minus 1 equals R. So R is equal to 0.2. So that would be A. And you could also say that's 20%. Now it says, what is the monthly rate? So, well, we have to say, well, the 1.2 is the growth factor raised to 112, then we have to subtract the original amount. So that's going to be parentheses 1.2, close it, raise it to 1 by 12, and then we subtract it. Gives us 0.015. Or 1.5%. Pause if you need to. I'm going to the next screen. Okay, you give this one a shot, see how you do. Okay, so your investment after 2 years is represented by the function 14,000, which means that's what was with your original investment. You have a growth factor of 1.15, and then it's raised to the T. So we need to look at your yearly growth rate. So 1.15 is equal to 1 plus R. So 1.15 minus 1 equals R. So R is equal to 0.15 or 15%. Monthly rate, we have to take the growth factor of 1.15. We have to raise it to 1 divided by 12. We have to subtract 1 from it. And that means it's going to be 1.15 raised to the 1 divided 12 and then minus 1. So that gives us a value of 0.0117, or you could say 1.17%, 1.2%. Something like that. Pause if you need to. I'm going to the last screen. Okay. This one's a decay problem, so remember the 1 is reversed in this situation when you're doing B. But we need to know the yearly rate of decay or appreciation. So when we think about it, we have 1 minus the rate is equal to 0.82. So that's the decay factor. So we're going to say 1 minus 0.82 is equal to R. So R must equal 0.18 or 18% for my yearly rate of decay. Now, for monthly rate, I have to put the 1 first and subtract the decay factor of 0.82 once I raise it to a 1/12. So 1 minus parentheses 0.82, close it, raise it to the 1 divided 12. And that's 0.06. Or 1.6%. And that should end the notes.